Hello viewers. Today's lecture on comparator and zero crossing detector. This is a topic of unit 4 of analog circuit. This is a basic circuit of basic comparator circuit. As you know, this is an open loop configuration because input signal is applied on non-inverting terminal, so that we can say it is a non-inverting comparator. As we know, the function of comparator is to compare one signal from with other signal. In this circuit, reference voltage is applied on inverting terminal and non-invert and input signal is applied on non-inverting terminal. Two diodes are connected, D1 and D2. These are used to protect the op-amp with excessive voltage applied on input terminal. These also clamp the op-amp at 0.7 and minus 0.7 voltage, so that they are also known as protective diode or clamp diode. Here the resistor R is used to control the current applied on this input terminals. Since we know the output of open loop configuration is given by VO equals to A VID, since VID is the difference of two input signals V1 minus V2, and V1 is the non-inverting input terminal, that is V in, V2 is the inverting terminal signal, that is the V reference, so that output voltage VO is A times V in minus V reference. Now it is, remember that when V in is greater than V reference, output voltage will be positive, and when V reference is greater than V in, output voltage becomes negative. This is non-inverting comparator with positive reference voltage. As you can see in the waveform, when V reference is less than V in, you can see here with arrowed line, here V in is greater than V reference. For that case, output voltage becomes positive because V in is applied on non-inverting terminal. For another case, this arrowed mark, in this case V in is less than V reference, so therefore output voltage will be negative or minus V saturation. So that we can say here, we can convert this sinusoidal signal into an rectangular signal, or we can say analog signal can be converted into digital signal. So this is also analog to digital converter, are also known as voltage level detector. This is the discussion for positive reference voltage. This is a circuit when reference voltage is negative. Again, you can see here, for this case, when V in is greater than V reference, since V in is applied on non-inverting terminal, output voltage becomes positive and it is equal to plus V saturation. And for this case, input voltage is less than reference voltage, and since input voltage is greater than reference input voltage is applied on positive terminal, the output voltage becomes negative. And we have discussed earlier that in each case uh, the output voltage cannot be exceed with the help of by saturation voltage plus minus V saturation. In this way, we can convert analog signal into digital signal or sine wave into rectangular wave. This is in rectangular wave because the pulse width of positive half cycle and negative half cycle are not equal. If the reference voltage made varied, the pulse width will also vary. If the reference voltage made equals to 0, the positive pulse width and negative pulse width will be equal, and that is the special case of basic comparator. This is the discussion for negative reference voltage. This is all about comparator, and this is the zero crossing detector. This is the special case of voltage comparator where reference voltage reduced to it is reduced, yeah, we can say reference voltage is 0 volt. Again, protective diodes are connected there to control the accessing voltage. Resistors are used to control the current. Since for this circuit input voltage is applied on inverting terminal, so it is an inverting comparator. For this waveform, we can see here 0 voltage line is also a reference line, and the sinusoidal input signal compare with this reference line, reference voltage. For this case, when V in is greater than reference voltage, since input voltage is applied on inverting terminal, the output voltage becomes negative. And for this case, when V in is less than V reference and input is applied on inverting terminal, so that output voltage becomes a positive voltage or positive saturation plus V saturation. You can see here in this case the output waveform is exactly a square wave, so that we can say zero crossing detector is a square wave to it is a sine wave to square wave converter. All about the zero crossing detector. It is also, there are some limitations of ZCD or zero crossing detector. It will change the level positive to negative with respect to input voltage. If there is some noise, the output will also fluctuate between two saturation level, plus V set to minus V set. This problem is overcome by using positive feedback, and that circuit known as symmet trigger. Thank you very much. If you have any doubt, you can ask me. Thank you.